Okay, now we're going to look at the application of this total annual inventory cost equation. Okay, so what does this three equation that I write on the screen here, which is on your, I believe you already copied down in your tutorial handouts there. So on this graph, y-axis is your annual cost, x-axis is your order quantity Q. Now what happened to the carrying cost? Your carrying cost is given by this equation that I copied just now. So carrying cost will increase with the order quantity, right? The carrying cost will always increase linearly with your order quantity, right? You buy every time increase, right? Another one is the ordering cost. Ordering cost will inversely with the carrying cost, but in the parabolic manner. Will inversely with Q because the equation is 1 over Q. So if you plot graph 1 over X, 1 over X graph, it will show this way. This is Y equal to mx. The Q is mx, right? The gradient is positive. So you get a straight line. So you combine these two lines because your total cost is ordering cost plus carrying cost, right? This one plus this one. So how do you get this point? This point is you pick this point plus this point, you get this point. How you get this point? Again, pick one point here, add these 2 points together, you get this point. So the combination of these two line value, you get a smiling face curve, total cost curve. On the curve itself, because if you're referring to the y-axis, you know where is the minimum of the total cost, right? The annual cost that you need to spend, minimum at this level. Not here, but here. This you expand to the left, it will give you the minimum total cost here. In your mathematics, how do you find the minimum cost of a quadratic curve? You take what? dy over dx equal 0 for this point, right? You learn in your SPM or secondary school government exam, right? Find the slope at the maximum point of that quadratic curve, right? You learned before. This is a quadratic curve, right? Smiling face. A equal to ax squared plus bx plus c. You find this one. Dy dx equals 0. You find this point. You project down, you get the optimum order quantity for that order, right? So this is how you find your minimum order quantity in the basic EOQ model. Make sense to you? The shape of the graph makes sense to you? Right, you are combining two parameters here, carrying and ordering cost. You combine the two costs together, you get the black color line. Okay, I think you have this one in your handouts. You're going to apply information on these slides, either the equation or the graphical presentation in the tutorial or in the example. Okay. Okay, there are some few steps right here just to give you some convenience when you do your revision. To determine the lowest point of your Q, or not lowest point of your total cost to find the optimum Q at x-axis. What do you do? How to find this point? You equal your carrying cost equal to ordering cost. You equal This point here, you equal the two causes together. Okay, this is just a mathematics equation. You take the total annual ordering cost, this one, plus this one in your equation. What is the calculation for order cost and carrying cost? This one. This one equal to this one. Okay, you have these two equations that you copy in your handouts, right? Ordering cost equal to carrying cost. Can you do simplification? Your 2Q, right? You want to find your Q, right? Inside this equation, there's only one Q, right? Oh, okay, you can say 2Q lah. But when you rearrange, you can get 1Q on left hand side, right? You know how to rearrange, right? So put your Q in one, either left hand side or right hand side. So Q, you move from left to right, it become multiply. So if you move your Q to right hand side, you get Q square. Then you move your 2 to the left hand side, move your CC to the left hand side. Okay, then you eliminate your Q square. Your square you move to the left becomes square root. Can you see the mathematical model? The objective here, the final objective here is to find the Q. You're using this equation or this relationship, this equal to this one. Rearrange the equation, you get your Q. Okay, it's just a mathematics from here to here. Rearrange, you want to find your Q, so your Q here is Q optimum equal to square root 2C sub O, or your ordering cost, demand divided by C sub C, right? Okay, copy this one in your handout because later you need to use this one in your calculation. All right. Once we know there is an equation to help us to calculate, okay, there's another way lah. This is the right way. Another way I show on the screen here. You can use differential equation like what I mentioned just now. How you find this point? This is a quadratic equation. How you get this point? You do dy dx equals 0, right? Same. You pull total cost divided by Q. Y total cost divided by Q basically is your Y and X. How you find the minimum point or maximum point of a quadratic equation? Dy over dx, right? So you put what is your Y? Y is your total cost. What is your X? Your X is Q. So your dy dx, your dtc dq equal, I straight away do the differential already. You do dy dx in this equation. If all these are confusing to you, you change tc to y, you change your q into x. Y equal to this one, y equal to cd divided by x plus cx divided by 2. You're having a y and x relationship. Dy dx, do differential equation. Right? Do differential or so do derivation. Differential. Do differential. Dy dx. In this case, we take the tc divided by tq. So this one is your x, right? Dy dx 1 over x, or this one maybe complicated to you, is 1 over not 1 1 not 1 1 over x is equal to x power negative 1, right? 1 over x equal to x power negative 1, right? So this one is 1 over q. You differentiate x, you get 1, right? You differentiate x minus 1. So minus 1, you get minus 2 divided by minus 1 put to the front. And then the bottom one, you have the square. Okay. This one is differential. So you need to go back to your mathematics lecture if you don't understand how to do differentiation. So this one become this one. There's a negative sign there because of the differentiation. This one also same. You differentiate x, right? You differentiate x, you get 1, right? So q gone. You only get cc divided by 2. You assume this one as constant. You differentiate 4x, what do you get? You get 4, right? So why 4? Because x minus 1 or you get 0. X0 is 1. So get this one. Okay, again, here to here is basically differential equation. If you don't understand, go back to your mathematics textbook. Go and flip to the differentiation equation. So once we get this one, and we know that how to get maximum minimum of the quadratic curve equals 0. So left hand side 0. You rearrange. Our objective is to find what is our q. You arrange this one, you will get the same equation. Q equal to square root 2c d divided by cc. You get the same. Two methods. One, we use differential. Another one is use carrying cost equal to ordering cost, meaning this point. How to find this point? This point actually is the intersect of two lines. So at this point, ordering cost equal to carrying cost at this point. Two methods. Okay. Then once you have the quantity, right? Once you have the quantity, next question, how do you find this minimum cost? Once you have the quantity already, how do you find minimum total cost? You have the quantity, you want to find the total cost, right? Let's say burger story again. Let's say you already know your optimum quantity you every time you order is 100 burger meat. What is the minimum cost for that order? You already know 100 packet of meat you need to order almost every day. You know the price tag of one meat, right? One packet of meat. So when you multiply the quantity and the unit price, you get the cost, right? This is a simple business equation. So here, you can use the equation that I told you, or you substitute into the total cost equation. But now the Q, you use back the optimum. Okay, sorry, this side. The Q here, you change to Q op. You substitute Q optimum here, Q optimum here. You find the TC minimum. Okay. Here you have two components. One is order cost and carrying cost. You are considering the two factor. Ordering cost, carrying cost. Okay, makes sense to you. The purpose of finding Q op is to find minimum total cost. How to find minimum total cost? Find the Q op first, substitute Q value there. Once you find this one, substitute inside there. Let's look at example 2. Okay, spend some time.
Doctor,
yes, go ahead.
Sorry, just a few seconds. I want to copy the formula.
Okay. You have copied just now already, this one. Important is this one. Then in your note, you just write substitute this one inside here. Substitute this one inside here. To find the minimum total cost.
Okay, Doctor.
Okay, look at example 2. Even you can read on your tutorial handouts. So what do you have here? It gives some information, a lot of information here. So it gives you a scenario where you have a e-paint store stock. So this company is selling paint, paint, and sell it online. So you're doing an online business. So the store stocks several brands of paint. However, its biggest seller is this brand. The biggest seller, that means the most popular product they sell, is SWI paint. Just in short, I just call it iron coat paint. Iron coat paint. The company wants to determine the optimum order size and inventory cost, which is the equation that you just copied just now. Okay, the optimum order size, which is the QOP, and the total inventory cost. That once you find the QOP, you substitute back to the total cost equation. All right. Okay. Given an estimate annual demand, you are given the annual demand. The D is given. So D is 10,000 gallons. Annual carrying cost is given, which is your CC, capital CC. Right? Annual carrying cost is $0.7 per gallon. Ordering cost also given. Ordering cost, which is your CO, C sub O, ordering cost, 150 per order. They would like to know the numbers of orders that can be made annually and the time between orders, which is they need to know the order cycle. There are lots of mission here, a lot of objective here. You need to find optimum order size. After that, you find minimum optimum size, and then you need to find the optimum minimum order, and you need to find the lead time, the order cycle. Okay. To find the QOP is not difficult. As long as you know the information, substitution, you already can find the numbers. Okay, I highlight all the important keywords here. Order size, inventory cost, number of order, and the order cycle. Okay, this is the equation they're going to use. QOP equal to square root something. And the total cost equation with the QOP value there. Basically, this one was given. This one was given. This one was given. You can find your QOP already. This one was given. Demand was given. CCs was given. 2 was given. You can find the total cost already. All right, just now I already tell you which one is which one. So CC is 0.75. CO is 150. Demand is 10,000. So you have CC, CO, and D. Basically, you can find this one. Right? Substitute this into here. Press square root. You can find your QOP. After QOP, substitute QOP here. CO you have, D you have, CC you have, QOP you calculated. You can find your total cost minimum. Okay, yeah? So this one already on the question already. So I give you a reference answer. Okay, I think I'm very kind already. I go and give you the detailed calculation. Okay, normally I don't do but this example I give you. So QOP you get 2,000 gallon. QOP you have two components, order cost and carrying cost. So from here, you know, from here, from this equation alone, you can know what is your carrying cost. Order cost, carrying cost, because this is order cost, carrying cost. So minimum order cost is 750. Minimum carrying cost, because there's a C there, 750. Again, this one also agree with the assumption in our derivation equation for QOP just now. How we find QOP? QOP equal to when you derive the QOP, the cost equal to cost, right? The cost O equal to cost O. So this one agree with our derivation just now. So your total minimum, minimum total cost will be 1,500 from the calculation, from the substitution of equation. So copy 2,000 and 1,500 as the answer for QOP and total cost minimum. Already solve for optimum size, which is your QOP. Ultimate order size, it is 2,000 gallon. Total inventory cost, this one. Okay, this one is the optimum case, optimum case. Okay, I put in the information over here, right? Okay, then number orders per years. Just now I put on my screen just now. Maybe it's a bit small on the screen, but just now I mentioned there's a combination of D divided by Q. Demand divided by your Q is the number of order per years. In this case, we use the optimum numbers. Q divided by Q op. You have your D just now, 10,000. Q op, you calculate 2,000. So your numbers per order per year is 5. 5 order per year. Solve for this one. Okay. So I put it here for info. Your number of orders is 5. 5 order. You substitute your D value, which is 10,000. Substitute your Q op 2,000. Here you get 5. Next. Okay, this information is not inside the tutorial question, but in normal operation or normal production floor operation, working days is 311. How you calculate 311? 365 minus the holidays. 365 minus 52 Sunday minus Thanksgiving and Christmas. This one is in the Europe setting. So you get 311 days per annum. Malaysia might be a little bit lower because we have a loss of public holiday, and each stage maybe have extra holiday because of the king's birthday or the sultan birthday, right? And even this coming Friday is Sembilan yang di-Petua birthday. So this Friday is Sembilan holiday again, right? So we have 311 days annually for this example. So how to calculate the order size circle? You take 311 days divided by the numbers of orders per year, right? 311 day divided by the numbers that you calculate just now, 5 order per year. When you divide is 62.2 days. Order cycle time is 62.2 days, meaning after 62.2 days, there will be another new cycle happen. Means new order you need to start after 62.2 days. Okay, 62.2 days. You take 311 divided by the number you calculate just now, 5 order. You get 62.2 days for your order cycle time. Okay, I put it on the slides here. 52.2 days. Okay, next you check the Q quantity. This is extra already. We already solved the question 2 already. From the top until the last one. This green color is the one you can extract from the question. Red color one is the expected answer. From the calculation, the Q op, this is just additional information for you. In the Q op, is actually reduce the error of calculation already because of the square root. if you have error in your cost, your demand and cost again, order cost or carrying cost, and you have a square root, it's actually minimize the error. Let's say you have error plus minus, let's say you have some wrong calculation here. The cost may be plus minus 2. Here, cost of carrying cost also plus minus 2 or plus minus 10. But when you do calculation with the square root, right, every time you square root, you make the number smaller. So actually the error also smaller. Academic word or technical word, we call it damp. The error was damp. D-A-M-P. Damp means it's like vibration. If you take vibration module this semester, right? The vibration peak and bottom, how you make the vibration become, the amplitude become small, you damp the vibration, right? You put in some filter, something to damp the frequency. Here is explain why when you use this equation, the error actually very, very small. This is just an illustration. So if the order cost here had actually been 30% higher, so if you increase the order cost, what is the order cost? In this case, order cost is 150. If you accidentally you do the wrong calculation, 150, you increase to 30%. Let's say there's an inflation rate, 150 increase 30%, you get around 200, right? So 200, even you increase this one, if you do comparison with 150 here, right? Because this is 150 my original, but you try to change this value to 200. If there's an increment of your cost in 30%, your Q-op actually is also not very much. Your optimum will be around 10%. You'll get your Q-op will be around 2190. Okay. Your calculation with the case given is 2000. So it's about 10%. It's about 10%. So 10% for business is normal. Okay. If you're in business, you know, when you have family members that in business and you sell things, normally the markup price, markup price. If your cost of a pen of item is 2 ringgit, normally you will sell at least 30% of your raw cost. Minimum 20. It depends on the cost lah. If the item is too expensive, like 1,000 one, maybe it just mark up a few, it will be more than 10%. Okay, more than 10%. So actually this 10% for business is very, very low. It doesn't affect a lot. Okay. So this is just extra information for Q-op. Okay, I think we stop here. Next class we do production quantity model. Okay. Today we do basic. We already done the basic quantity models. So there are three equations, maybe 4. Okay, 3 equations just to recap. One equation, 2 equation, 3 equation, means this one as you can count as 3 equation plus this one 4 equation. Okay, then try to understand this graph. Okay, this is under basic EOQ model. Then you use all this calculation to solve EOQ. Then next lecture we will see what is the difference with production model. Okay, let me stop the recording.